The phenomenon of rising temperatures, which began to noticeably impact global climates from the late 19th century onwards, has emerged as one of the most significant environmental challenges facing humanity today. This trend is primarily driven by human activities such as burning fossil fuels and deforestation, leading to an increase in greenhouse gas concentrations in the Earth's atmosphere. The earliest records indicate a rise in average global temperatures around 0.2 degrees Celsius per decade after the mid-19th century, with more pronounced variations observed during distinct periods like the late 1930s and early 1930s, when World War I. The emergence of this phenomenon has been marked by key developments, including the Intergovernmental Panel on Climate Change, IPCC, reports from the mid-20th century, which first established a link between rising temperatures and human activity. Notable turning points include the signing of international agreements such as the Kyoto Protocol in 1997, aimed at reducing greenhouse gas emissions by approximately 5% below 1990 levels, globally over 10 years. The measurable impacts of these rising temperatures have been significant across various sectors, including agriculture, where yields have declined due to changing precipitation patterns and increased stress from heat waves. Additionally, the melting of polar ice caps has led to rising sea levels, threatening coastal communities with possible inundations by 2100 in some regions. Economically, it is estimated that climate change-related damages could cost up to $54 trillion globally between now and 2100. Major consequences include increased frequency of extreme weather events such as heat waves, droughts, floods, hurricanes, and wildfires, affecting millions around the world annually. These factors often result in loss of life, property damage worth billions, and disruptions in essential services like electricity supply. The benefits of mitigating climate change, however, include improved public health through reduced air pollution and healthier ecosystems. Looking to the future, continued efforts towards reducing carbon emissions are crucial, as they could prevent global average temperatures from exceeding 1.5 degrees Celsius by mid-century, a critical threshold set out in the Paris Agreement aimed at limiting warming effects. This would require substantial reductions of greenhouse gas emissions, such as phasing out coal use and transitioning away from fossil fuels to renewable sources of energy like solar, wind, and hydroelectric power. Given these projections and recommendations, AI-driven optimization could play a vital role in managing climate change by providing accurate data for policy decisions, efficient deployment of clean technologies, and dynamic forecasting models for predicting environmental impacts. This would help ensure sustainability and resilience across societies and economies into the foreseeable future.